Blockchain holds the potential to revolutionize every aspect of our online lives. And one industry in particular that's prime for disruption is real estate. I mean, think about it. Real estate's a pay-to-play system. Property ownership can easily be modeled on blockchain with NFTs. And the transfer and sale of property can be made way more efficient using blockchains and smart contracts. Because honestly, like most of the real estate industry lives in the dark ages and how it does things now. And in this video, I'm gonna show you how to create a blockchain-based real estate app just like Zillow, where you can buy and sell real estate completely online with cryptocurrency and smart contracts. This is an amazing project to learn the fundamentals of blockchain development, how NFTs work, and also to use for your portfolio if you're trying to land a highly paid Web 3.0 job. And you don't have to be an expert to get started on this today. You'll learn all the programming languages, skills, and technologies as you go, like how to create the smart contracts with Solidity, how to write tests in JavaScript, how to make a website with React.js, and how to put the project on a blockchain. So I'm super excited to show you this today. So if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you want to learn how to become a blockchain master step-by-step from start to finish, land your first Web 3.0 job, then head on over to dappuniversity.com/bootcamp to get started today. All right, so let's take a look at what we're going to build today in this video. So we are going to create a blockchain-based real estate website inspired by Zillow, okay? So we're going to call it Millo. And basically, this is going to let you, list properties online with the blockchain and let people buy them directly with their blockchain wallet. So you can see we have a luxury penthouse in NYC here. We'll click buy. Okay. We also have an entire process to go through a real estate transaction, like escrow, like lending, like inspection, all that type of stuff, where we streamline this entire thing with blockchain with non-fungible tokens or NFTs. And so let's take a look at a diagram of how this full stack application is going to work. Okay, so basically a user is going to connect with their wallet like MetaMask. Okay, you can see that on my screen here. And essentially they will talk to this website. All right, we're going to code this website out in, JavaScript with React.js. Okay, and then this website is going to talk directly to the NFT smart contract that we have created for this application. Okay. So this is our full stack React app, and it's going to talk to this. Okay, so this is the blockchain side of things, and each property is going to be represented by an individual NFT. And when we click the buy button here, it's actually going to put the property in escrow so that it has to be approved, by other parties and funded before it can actually finalize the transaction. And the ownership of the property will change based on the NFT. To the seller. And so let's dive in specifically to how the blockchain side of things works, okay? So we are fundamentally going to create an NFT to manage our properties, okay? It's going to be an NFT collection that manages all of the different properties, all right? So we're going to create that non-fungible token with Solidity, the primary programming language for Ethereum and other EVM-compatible blockchains, okay? We're going to develop that with the Hardhat development framework, okay? We're going to write tests for it. We're going to deploy it to the blockchain. And we're going to use the ERC 721 standard, which is the standard for non-fungible tokens or NFTs. Okay, so we'll create a fully ERC 721 compatible NFT in this video. But now let me also talk about the pictures for the NFTs. Okay, so whenever you look at the NFTs on here, you see like the image of the property, and you see these other things like the purchase price, the type of residence, bedrooms, bathrooms, all this extra information about it. So this is what's called metadata for the NFT. So all these, attributes are metadata. And then also this picture right here is a form of metadata. And so we don't want to put this information on the blockchain itself, okay? So we're going to use something called IPFS, and that's pretty standard for NFTs. That's called the Interplanetary File System, okay? So basically, IPFS kind of works. This is not the actual IPFS. Hold on. IPFS kind of works like a blockchain. Okay, it's not really. It's basically just a decentralized, file storage system. Okay, so basically, it's just a distributed network of nodes that store files in a censorship-resistant way. Okay, and so that's what we're going to use this for. Basically, put our pictures on IPFS. We're going to put the attributes of the properties on IPFS, and that's going to essentially store a reference to each of those inside of our NFT smart contract. I'll just show you a quick example of that, what it looks like. So here's an example of like some JSON data. This is the metadata for the NFT. You can see the purchase price, type of residence, number of bedrooms, bathrooms, all that type of stuff. This is for the actual IPFS metadata for this property that we saw right here, okay? And then for the image, you can see a link to it on IPFS with the link right here. And then here's an example of the hosted image, okay, on IPFS as well. All right, now finally, let's look at basically the escrow process and how a sale will work. So again, we're going to have this real estate NFT. All right, let me actually move this font down so you can see a little better. All right, that's the NFT we're going to code first, where essentially we just create a smart contract that governs the property. But we're going to create this second contract that actually facilitates the purchase. This will be an escrow contract, where essentially you have a seller, all right, that will put the property in escrow, and the buyer can put in a down payment. All right, then you have all these other parties involved, like a lender, an inspector, an appraiser, and they actually have to go through and sign off on this transaction that it's valid before the ownership of the NFT can actually be transferred, okay? So we'll code all this out, we'll write tests for it, we'll show you how it works, and we'll put it in this full stack application so that all this can be done directly through their website in a decentralized way that can completely streamline this process. All right, so let's go ahead and get started here. So let's start coding. There's only a few dependencies that you need in order to get started on this. You, of course, need a terminal, okay, so that you can execute commands in your terminal. You need a text editor. You can use whatever text editor you'd like. I'm just using Sublime Text because it's my preference. You need a MetaMask wallet installed so that you can make transactions on the blockchain, okay? But in terms of actual developer dependencies, the biggest one you need right now is just Node.js, okay? So you can go to your terminal, see if you have Node installed, do Node-V, okay? I'm using version 16.14.0. You can use whatever version you'd like, but if you're, just brand new, I highly recommend sticking to my same Node version to reduce the possibility of any problems that you're going to run into, okay? So if you don't have Node installed, you can install it with the package manager, or you can just go to the Node.js website directly and then download it for your machine, okay? So let's go ahead and get started with the code. I'm going to put a link to this down in the description below. This is the GitHub repository for the final code solution, okay? I've created a starter branch for this particular project. So we're not creating every single thing from scratch, okay? We're going to start off with a little bit of a template here today so we can get moving quickly. The biggest thing is I want to show you how to do this with real estate NFTs and create this full stack website with React, okay? So go ahead and grab that link down in the description below. All right, copy it. I'm going to go to my terminal, and I'm going to do git clone. All right, and then I'm going to say -b. So that's going to clone a specific branch. So Git has branches. It's just different versions of the code. I can see my branch here called starter code. So git branch -b starter code. All right, and then I'm going to put it in here. All right, and then that's going to clone into this Milo directory. So I say cd Milo. All right, now I'm on this branch starter code, which is exactly where we want to be. So once you're inside of here, we can go to open it up in our terminal. Okay, you can see that it's got some placeholder for some contracts inside of here. And so this contracts directory, we've got some front end already configured inside of our project here, okay? So it's not created, it's just we got some configuration set up so we can get moving quickly. We've got a directory for the test, okay? And we have our package.json, which is what we really want, which are all the dependencies for our project. So let's go ahead and install those. We can go to our terminal and do npm install. All right, that's going to populate our node modules directory here and then pull down all the dependencies that we need. So what are some of those dependencies that we're going to use specifically for this, okay? So we're going to use Hardhat for creating the smart contracts, okay? So you can see that down here in the dev dependencies, all right? So Hardhat is a smart contract development framework that's going to let us, create smart contracts. It's going to let us write tests for them, put them on a blockchain, and all that type of stuff. So Hardhat's a really great tool. We're going to use Ethers.js, all right, for talking to the smart contracts in JavaScript, okay? So Ethers, comes inside of Hardhat as well. Okay, it's pretty standard. So Ethers, I'll put that up here. All right, Ethers is our JavaScript library for interacting with Ethereum and interacting with smart contracts. So that's what we're going to use for that. And then finally, we're going to use React.js to build out this client-side website. Okay, and again, React is just a JavaScript framework for creating user interfaces. All right, so now let's get into coding our first smart contract, okay? So what we're going to do is create a smart contract specifically for the real estate NFT, all right? So we can go inside of this realestate.sol file, okay? So realestate.sol is our first smart contract file, okay? Capital R, capital E, That's the convention for naming Solidity files here. .sol is the file extension. And you can see here we have at the top our Solidity programming language version. We just do pragma Solidity with a caret version 0.8.0. And then we use the contract keyword here. And then we give it any arbitrary name that we want to. In this case, we're going to call it real estate, just like the file name. And so all the code for the smart contract will go inside of here. And of course, to say the obvious, this is the Solidity programming language that you are looking at right here. Okay, so what we're going to do instead of creating a complete NFT from scratch is we're going to use a third-party library to help us create the NFT quickly. So we're going to use the OpenZeppelin library for doing this. So OpenZeppelin is a great project for open source smart contracts. NFTs are basically a solved problem, and just for the sake of getting started quickly, we can essentially use somebody else's audited NFT code to get started quickly. That's exactly what OpenZeppelin is for. So we already have OpenZeppelin inside of our project. We installed it with our NPM packages. So we can just import the OpenZeppelin dependencies into our file like this. So we can import the smart contracts like this, and then we can inherit from them in our smart contracts by saying like contract game item is ERC721 full. We'll do a very similar type of process, okay? So I'm going to import them like this. If you want to grab this from the final code solution, you can. But basically, I'm going to say import OpenZeppelin contracts utils counters, okay? ERC721 and then ERC721 URI storage. So this is going to help us create our NFT. So we'll say real estate is ERC721 URI storage. Okay, that's the same thing as this right here. And that's basically going to let us get all the behavior that we need to create our NFT. So we'll do a little bit of boilerplate setup inside of here. Basically, we're going to say using counters for counters.counter and then counter.counter private token IDs. Basically, this is going to allow us create an enumerable ERC721 token so we can create them from scratch. So let me make a quick note of that. All right. So basically, whenever we create this NFT, we're going to mint them from scratch. So when we put the NFT in the blockchain, we deploy the smart contract out there. The smart contract out there. There's not going to be any properties whenever we create it. All right. We're actually going to create them manually from scratch, one by one by one, by calling the mint function. Okay. And that's going to create like property 1, property 2, property 3. And we'll do that after we've deployed the contract to the blockchain. That's why we're basically going to make this an enumerable contract where we can, create them. We're going to create a mint function. All right. And we'll also override the total supply to support that. But the first thing we need to do is basically give our contract some settings. All right, so ERC721 tokens, NFTs, take a name and a symbol, okay? And we can configure those settings into the constructor function. Again, this is the function that runs once and only once whenever the contract is created or put on the blockchain. Okay, so we can create our constructor. We can just copy this from the documentation. All right. And you just use the constructor keyword, ERC721 full, okay, game item, this, all right. So I'm going to modify this. So ours is going to be just ERC721, all right, just like this right here. And we're going to call it real estate. And we'll just use real. All right, we don't need this. We don't need the public. And we can just take off the function body because we don't need to execute any code inside of there. All right. And then next, we're going to create the mint function. All right. So this is what's going to let us, actually create tokens from scratch. We'll say function mint public returns UN256. All right. And basically what we're going to do inside of here is let somebody mint with a specific token URI. So this is going to be the actual metadata. All right. And then essentially inside of here, we're just going to create the NFTs from scratch like this. Okay. So we're going to update the token IDs. That's why we use this right here. Basically, the token ID is going to start at 0, and then we're going to increment it. We're going to add 1 each time. And then we'll turn a new item. All right. We'll mint it with the internal minting function from the library here. We'll set the token URI and return the new item ID. And then finally, we'll need to reflect that in the total supply, which is here. We'll override the total supply function to basically see how many NFTs have been currently minted. So I know I went through this part kind of fast, all right? And that's really to be intentional because I want to focus on the actual real estate escrow contract, which we'll focus on next. Okay, so the NFTs are kind of a solved problem in this case. I want to focus on the actual purchase behavior, and we'll code that out much more step by step with tests. Okay, but for now, I just wanted to get an NFT up and running quickly. All right, so that we can just have that NFT to work with. Because again, we're gonna go back to this process where we have our NFT contract here, and then we have this escrow contract that facilitates all of these different purchases. So let's go ahead and get started on that now. All right, so now let's move on to the second smart contract, the escrow contract. And this is where we'll get a little more in depth, a little more step by step, and actually the coding of the Solidity, because this is way more custom, from scratch. Okay. So again, what we're going to do here is create this escrow process where, a seller can list a property, a buyer can basically, signify their purchase intent and create a down payment. Lender can get involved, an inspector can get involved, an appraiser can get involved, and go through all this process to actually transfer the ownership. Okay. So what we're going to do first is create some settings in this smart contract. We're going to create some state variables. Okay. So opening up the file here again, what do we have? We have the programming language version at the top. Okay. We have this interface for an ERC721 token. We'll come back to this. Don't worry too much about it right now. We'll explain interfaces when we get there. But right here, we have the actual smart contract itself, the contract keyword, escrow. Okay. So this is the contract we're going to create. We're going to put all the Solidity code inside of here. So what we're going to do first and foremost is store some settings. Okay. So we're going to use state variables for this. And we're going to keep track of some different blockchain addresses. Okay. So like the lender. We want to know who this is, who the seller is, okay, who the inspector is, all right, all that type of stuff. So at the top, we're going to say address, okay, public, lender, all right. So what is this? So, basically Solidity is a statically typed programming language, which means you have to declare the address type. You have to declare the variable type whenever you're declaring a variable. That's why we use address here. That's just the data type of a blockchain address like you'd see in MetaMask. Lender is just the name of the variable we're creating. Again, this is a state variable, so it's going to get saved inside the smart contract on the blockchain. So once we set it, it's going to stay that way on chain. And then public just means that this variable is now visible outside the smart contract, and that Solidity is going to give us a special function for free where we can access this value and we'll be able to see it outside the smart contract. So we can do the same thing for the inspector. All right. And then we can do the same thing for the seller. But we change this to address payable type because the seller is the person who's going to receive cryptocurrency in this transaction. So we must make their address payable here because we're actually going to transfer Ether to them. And then essentially we're going to say address public NFT address because we want to store the smart contract address for the NFT for this particular real estate transaction. Okay. So next what we want to do is actually set all these variable values. So we're going to do that inside of our constructor function. Again, this is the function that's run once and only once whenever the smart contract is deployed to the blockchain. We can create a constructor like this, a constructor. Okay, we say address, NFT address, address payable, seller, all right, address inspector, and then address lender. All right, I'm going to kill my sidebar over here, and then we'll do some curly braces here. All right, and then open up a new thing. And what we're going to do is set these function arguments, these variables that are passed in to these values here. So again, these are state variables. All right, and these are function arguments, which are going to be local variables inside this function. So I'm using underscores as a convention just to prefix those so that there's no naming conflict. All right, so how we set this is like we just say NFT address, which is the state variable here. We can access this value and also set it inside of here. So we can say NFT address. Because it's a state variable, it's accessible everywhere inside the smart contract. Whereas this, function argument's only accessible inside this function, so we can read it right here. And we basically are just saying, hey, take this NFT address we passed in and assign to this NFT address here. And whenever we do that, it's going to save it, forever on the blockchain. So same thing for seller. inspector and lender, we'll just do those like right here. All right. So basically seller, we're going to set to this seller. All right. Inspector to this inspector, and then lender to this lender. And while I'm here, I'm going to format this code, all right, to be a little more readable. Instead of having it being way long ways like this, we're going to break it up in multiple lines. All right. So I'm going to do this. All right. And then I'm going to do that. All right. And so that's going to be our first bit of functionality, is just creating the contract with these specific settings and then actually passing in the NFT address that the escrow contract keeps track of it. Okay. So we're going to test all this out as we build the smart contract. We're going to write tests in JavaScript. Okay. That's the great thing about Hardhat, is it comes with the testing framework already installed. So if you open up this escrow, if you go to test folder, look up escrow.js, we can actually write tests in JavaScript that automatically check all the behavior of our smart contract, okay, without having to check everything by hand, all right? So I've already set up the testing environment here. I've got this expect from Chai, which is an assertion library. You'll see that we've got ethers pulled in. We have a helper here that helps us convert currency to tokens, all right? And then we have this function called describe escrow, and this is really where we're going to put all the tests for the escrow smart contract itself. So inside of here, what we're going to do essentially is we're going to start off with something called describe. We'll say, let's just do this. Let's start with a simple test example. We can say it. We can just say returns, NFT address. We'll just say it saves the addresses. All right, so this describe is describing the smart contract, and we can write a test example with this it function, and we can just tell it the behavior that we're looking for. We can say it saves the addresses. All right, and we can just pass in a function here. I'm going to use the async await pattern inside JavaScript, so we're going to make asynchronous function calls, so we need to do that. I'm going to call await on those. So what we're going to do, essentially, is we're going to deploy the real estate contract, all right? So we'll do that first. Basically, this is the real estate contract here we created. We can do that with ethers.js, all right? So essentially, ethers lets us just get the real estate contract factory from Hardhat like this. We can just say ethers get contract factory, all right, real estate. We can say that to a variable like this, a const real estate equals await, all right? And then that's going to basically get this compiled contract inside of Hardhat, but now we need to actually deploy it to the blockchain like this. We say real estate, equals await, real, let's do this capital, await, real estate dot deploy. All right. And then essentially, we're going to, check, we're going to just, first, let's just check the address. So we can say console, or we can, let's do it this way, console.log. Let's just say real estate address. All right. So let's do a quick smoke check, make sure that's all set up and working properly. All right. So let's do npx hardhat. So this is how we run hardhat commands. So we can basically run hardhat like this, hardhat tests, and then it'll run the tests. But because we installed hardhat inside of our package.json file here, we actually want to run it with the hardhat version that's saved to our node modules directory, and that's what we're using npx for. So we'll say npx hardhat test. Hardhat test. Okay, awesome. So that's how we run the test. It'll pick up that file automatically, run the test runner, and we can see our contract address was logged to the console here. So that's it's working for now. Okay, so it saves the addresses. Basically, all we've done is deploy the real estate contract and logged the address here. All right. So now what we want to do is essentially mint an NFT first. Okay. So we saw this here where we can call this mint function, and we want to pass in a token URI. All right, so we can actually create an NFT once we've done it for a property that we want to list on our, Millo website here. So we can use this, IPFS URL right here. All right, you can grab this from the final code solution if you want to. I'm just going to copy this and put it in my file here. All right, so I'm going to go to, I'm just going to put it here for safekeeping for 1 second. Take out this console logging statement. But in order to mint it, what I'm going to do is say, mint here. And here we can say, deploy real estate. All right, I'm going to say let transaction equals await real estate mint. All right, I'm going to paste in this URL for the metadata. All right, because that's what we need to do whenever we mint the property. It takes in a token URI, okay? And this is going to be the URI for the metadata that has the image inside of it. It's got all the attributes, okay? So that's how we'll mint it, just like this, all right? We'll do real estate mints. But from Hardhat perspective, we only want to do the minting from the seller's perspective, okay? So we want to basically call this mint function as the property seller. So how do we do that? Well, Hardhat will let us essentially act on behalf of specific accounts in this list. So basically, we can get all the accounts saved to our Hardhat project like this. We can do await ethers get signers. Okay, and that's going to log out all the addresses that come for free inside of Hardhat. Okay, so basically, whenever we run our Hardhat tests, we can essentially get an array of signers. So let's just log that. So say const counts. Or just say const signers. All right, I'll say console log signers. And then let's comment out this for a second because we don't want to do it just yet. But let's run the tests again. You'll see what's inside of there. All right, so you can see Ethers returns these 10 different signers. So signers are really just like people, like fake people on the blockchain. Actually, it's 20 signers. And it's like 20 different MetaMask accounts, okay, that Hardhat gives us for free behind the scenes, and they all have cryptocurrency inside of them, okay? So I can do like console signers.length to prove that it's 20 here. I believe it's 20. Yeah, 20, okay. And so each of them has an address as well, all right? And they'll let you sign transactions, put them on the blockchain. So what we're going to do is we're going to set the buyer and the seller in this case. So we could just say, or const buyer, and we could say, signers 0. All right, this is a 0-based index array. We say const seller. We could say signers 1, all right, because it's returning an array when it's reading out each account one by one, all right, and setting the buyer as the first one, the seller is the second one. Again, 0 index, so 0 is 1, 1 is 2. And so we could do that like that the long way, or we could essentially do parallel assignment inside of JavaScript like this and just do it like this. We just give it an array and say buyer, seller. All right, that's going to assign them inside the array. Okay, that way we don't have to do it one by one. And then we can essentially save these at the top like this. We can do let buyer seller. All right, let's actually do it outside of here because we'll change these and we'll access it out later. All right, and then also we can do the same thing for real estate like this. We can say let real estate. All right. And so the reason I did this is because we want to actually mint the NFT on behalf of the seller. So if I want to do it from the seller's perspective, I can say connect seller, all right? And then that's going to actually do this mint function on their behalf, okay? So transaction equals await real estate connect seller, mint the NFT with this metadata, all right? And then we're going to say await transaction wait. All right. And then we're going to do npx hardhat tests. All right, so it's still working. All right, nothing to really see yet here. But then now we have put a real estate NFT on the blockchain. We've minted a single property. All right, we have a buyer and a seller that we set up here. Now we actually want to deploy this escrow contract and then save the NFT address. Now that we have it, it's actually put in the blockchain, save the seller, inspector, and lender. So let's create some more accounts here. So buyer, seller, let's do inspector, lender. All right, and then do inspector, lender here. All right. And then let's deploy the escrow contract. So we have the real estate contract. We've minted it in an NFT. And then now let's do const escrow equals await ethers get contract factory, just like we did here. And then let's do escrow. All right. And then we can do, let's set a variable for escrow here. And let's say escrow equals await escrow dot deploy. And then let's put in the values we need. All right, we need the NFT address, the seller, inspector, and lender. All right, so what we're going to do is just pass those in, and we'll say real estate dot address. For the seller, all right, we'll do like this. We'll say seller dot address. Okay. So whenever we do this, this is the entire signer. It's not the actual blockchain address itself. You can get the address by doing seller.address. All right. So inspector.address and then lender.address. Okay. So now let's do that. Let's do npx hardhat test. All right. So that's still working. And then finally, let's just make sure that it checks the NFT address. So we can check that like this. We could say, let me just give myself some space so you can see it. Let's do const result equals await escrow dot NFT address. Okay, so basically what we're doing is we're reading this variable value right here, NFT address. Again, it's a blockchain address. It's public, so Solidity gave us a function called NFT address. And we can call that on the smart contract like this. We do await escrow NFT address. We save that to the result. Again, we're using the async await pattern in JavaScript. It's an asynchronous function. So instead of using like some crazy like callback function, we're just awaiting the result. Okay. If we didn't do this, it would return the promise, but you want to get the actual answer. So we wait for the promise to resolve. Okay. And then we can check it. We say expect. All right. We're pulling in expect here from Chai. Okay. Expect result to be equal. All right, real estate dot address. All right, and then we can also check that it returns the seller. It's basically the same thing here. We could say, const escrow seller. We want it to be equal to the seller address. Let's not do const. All right. Let's see here. Let's do let. All right. And then, so that we can check both of those. So I want to do a little bit of refactoring because I don't want to do all this inside of one big test. All right. So let's actually move. Let's reorganize this. So basically how we should do that is this should be its own, like this is one test example right now, like describe escrow. It says it saves the addresses. And what we want to do is actually have a specific test example for this and a specific test example for this. So instead of saying it saves the addresses, we're going to create a test example that says like, let's do it like this. We'll say it. Well, first of all, we're gonna have a special test example that says like it returns NFT address. All right, and we can say async. All right, and then we want to have a special function that basically says, it returns the seller. Okay, which basically we're just checking all this stuff. We're saying in terms of NFT address, seller, inspector, lender. All right, seller, returns the inspector. All right. And then, it returns lender. All right. And we want to put all these inside of a special describe block. So we say describe escrow. We're going to say describe deployment. All right. And that can be a function like this. All right. So we're going to move all this stuff inside of here. Okay. And each of these, instead of, we want to do all this stuff to set up these tests. And so we're going to take all of these and then basically put them inside of a before each function. All right. So let's do this before each. Okay. Say async. And what this is going to do is essentially run all this code before each of these test examples run inside this deployment description here. So you can basically take all this stuff. We've got all this stuff set up here. We can just copy all this, all right? Or just cut it all out and then put it inside the before each. Oops. All right. And basically here you go. So we've done all that. And then now we can say describe deployment. And for return the NFT address, basically we can just cut this out. All right, move it inside of there. And say we can say const result here. All right, see what I'm doing? I'm just organizing the code we already wrote into a much better test suite. And then we can say returns the seller. We can cut this and just say const results. Let's go ahead and take that out. All right, let's just run the tests and make sure the exact same tests are passing, but it should be 2x test examples now, all right, instead of the first one. To npx hardhat test, see if we got any issues. All right, still working. Now let's go ahead and add the other ones. So I'm just gonna copy this, put it inside of here. So this should be inspector, and then inspector, and then lender. All right, so let's save that. And boom, it passes. All right, so now that we've created the basics of this escrow smart contract, really just the constructor function that, tracks the settings for the smart contract. It also, we've got some basic tests set up. We're going to be, positioned to move more quickly throughout this because now we can write tests to make sure that the code that we're writing in Solidity is actually doing what we expect, okay? So now let's go ahead and work on the first bit of functionality, which is listing a property, all right? So essentially what we can do is create a function here called list. We'll say function list, all right? We'll call this public, all right? And inside of here, what we're gonna do is essentially just take the NFT out of the user's wallet and move it into escrow. And we're going to do things like, set the price for the NFT or the property in this case. We'll put in the escrow amount, which is required, essentially like, a down payment or earnest money, okay, whenever the transaction is going to get completed, all right? So let's start off with the first bit of functionality, which is moving the NFT out of the user's wallet and actually putting it into escrow, because that's the whole point of a real estate transaction with escrow is that the ownership is put in by a neutral party and then everybody else has to sign off and do what they're supposed to in order to, make this happen. Again, if you have seller, basically the seller lists the property, they're going to put it into this escrow contract. And this is not perfectly how a real estate transaction happens in the real world. We're just kind of modeling this so you can see how it works in a simple fashion, okay? Typically the buyer deposits for earnest money, and then you have this appraisal, inspection, all this type of stuff, right? So let's start off with the first thing, which is actually taking the NFT out of the user's wallet. So what we're going to do is use an, first of all, we need to know the ID of the NFT. So again, we created an NFT right here with this mint function. This is going to be the NFT with the ID of 1, all right? But you could have multiple properties like property 1, 2, 3, 4, 5, 6, okay, from this collection. And we need to know which NFT it is. So the first argument inside this list function It's going to be uint 256. And we'll say NFT ID. All right, that's going to be the property that's getting listed. And the first thing we can do essentially is just transfer the NFT out of the seller's wallet into this escrow contract, and it'll stay there until the sale is complete. So we want to say, so how do we do that? Well, we coded this NFT in a different file here. Okay, so we could import this file into our contract and call the transfer from function, which is the function that is part of the ERC 721 standard that moves NFTs between wallets. Okay, you can see that here. All right. So all ERC 721 tokens, including the one that we have created because it's the Open Zeppelin version, has this transfer from function, okay, which basically says, here's the from address, here's the to address, and the token ID, all right? And because we know the seller's address and we know the smart contract address, we can just move the token out of the seller's wallet into our wallet once they've approved it. And then now we will have the thing in escrow. So we need to talk to our real estate contract, call this transfer from function that was provided with this library, and move the NFT into our escrow contract. So how do we do that? Well, again, we could try to import this, okay, but we're going to use something called an interface. I said I would come back to this earlier, and I am now. So essentially, an interface is sort of like a skeleton for a smart contract that just tells you the types of functions that are on side of it, okay, in Solidity, so that we can talk to those types of smart contracts. So really, we just want to say, hey, we use this I prefix as a convention for interfaces, and we're saying, hey, here's the basic interface for an ERC 721 token. This is not the complete smart contract code, but we're going to tell you there's this smart contract out there that has a transfer from function on it. And so we're going to use this thing called an interface to just communicate with that. We don't need to know anything else about it, like any other functions. We just care about this particular function right here. So what we can do is basically say ERC 20, all right? And then we can pass in this NFT address, right? And now this is going to let us do is get a version of this NFT inside of our project where we can call the functions, in this case, the transfer from function. All right, we can actually call the transfer from function on our NFT because we have the address and the interface, all right? And then we can pass in basically the seller's address. So in this case, that's going to be the person calling the functions. That can be message.sender. All right. And then who's it going to go to? It's going to go to this actual smart contract. That's who's going to get the ownership. So we can get the address of the contract that we're coding inside of with address this. Okay. So this is literally the smart contract in this case. It's a global variable inside Solidity. And we just make sure that's an address like this. Okay. And then we're going to pass in the NFT ID, which is going to be what we passed in right here. Okay. So you can see that, again, the NFT ID is this. This is the address from, our address to, and token ID. All right. So now let's write a test for this. Okay. Let's write a test to make sure that this basic functionality of listing works. Okay. So inside of the test, we're going to go down here, and after describe deployment, we're just going to copy this block and then say describe listing. All right. And so I'm going to take out all these test examples. I'm just going to start with this first one here. And what I'm going to do is say it, I'm going to say it updates the ownership. Okay. And so here what we're going to do is we're just going to check that the owner of the NFT is now the smart contract instead of the previous owner. And so how do we do that? We can say expect wait real estate owner of one. That's the first NFT we created. And we can say to be equal and then pass an escrow dot address. That's going to be the address of the smart contract for the escrow contract. Okay, so let's just run the test, see if that passes. Okay, so we got a little issue here. We got a compilation issue. So I said ERC20. That's my fault. It's a stupid mistake. I'm thinking of ERC20 tokens. Sorry, everybody. ERC 721. All right, run the test again. Okay, so It didn't work. That's okay. And I'll tell you why in a second. But let's just go back and look at this. Okay, so how do we get owner of, first of all? All right. So owner of comes from the ERC 721 spec. Okay, again, we're going to get this function for free because we just pulled in a library, but you can see the, owner of address, owner of function. Basically, you can put in the token ID. It will return the Ethereum address or the blockchain address of the wallet that owns it. Okay, so in this case, the ownership hasn't changed. All right, so why is that? Well, you can see, we run our test. The test is correct, but the behavior isn't actually working. Well, that's because you can see inside the contract, we're doing this transfer from function, which moves a token from one wallet to another. But, we haven't done a critical step on the other side of things, which is approving the token. Okay, so transfer from lets you move tokens from one wallet to another. But really, anybody can theoretically call this transfer from function. I mean, that's what we're doing inside of this smart contract here. Okay, so we have to have the owner's consent to move tokens out of their wallet to this smart contract. Okay, so how do we do that? Well, the owner of the token itself can call this approve function right here. All right, so the owner must call approve before we can actually call this transfer from function and move the tokens out of their wallet into this contract. So that'll be a required first step. So we can do that in our our before each function here. So essentially what we'll do is we'll have the seller, approve the property. We'll just say approve property, and we'll say transaction equals await real estate connect seller, and we'll say approve, and we'll say escrow address, and we'll do token ID of 1. All right, so wait transaction wait. All right, and then now we need to actually list the property as well. So we'll say list property, and now we can say transaction equals await escrow connect seller lists. So this is going to have our list function here. We pass in the NFT ID. All right, and we'll say await transaction dot wait. Now it should pass if I didn't make any mistakes. All right, so it updates the ownership. So now after on listing, it updates the ownership. Okay. So owner of 1 is now the escrow address. All right, so awesome. So next thing we want to do is actually, so I'll put a comment inside of here first of all. Put a comment and basically just say transfer the NFT from seller to this contract. Now we want to do is update the listing status. So basically we want to store a special place inside of our smart contract to say like, hey, this particular NFT, is it actually listed? So what we can do is create something called a mapping inside Solidity. So this is like stores key value pairs. So we can say mapping. All right, we can give it a key value of UNT 256. And then bool, which is a true or false value. Say public is listed. So I'll dig into mappings a little more. So the key, it's just a data structure that gives a key and a value. So a UNT is an unsigned integer. So basically it's a number greater than 0, all right, with no decimal places, all right? So sign just means like a minus sign, right? So it can't be negative. So basically, that's what a unsigned integer is of 256 bits. And then a Boolean is just a true or false value. So basically, this will be like the NFT ID, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this will just be like true or false. And that will basically tell us, is the property listed? Again, this will be public. All right, so we'll have a function for free called is listed that we can check for outside the smart contract. We can update this mapping right here. It's kind of like a little database where we'll just say, is listed. All right, and then we say NFT ID, and then we say true. All All right, so that's how we assign values to a mapping. We give it the mapping name, we give these brackets, all right, pass in the key, which is the NFT ID. In this case, it's just 1, and then we assign that to true. All right, now we can check for that inside the test. We can say, it updates it as listed. All right, so instead of updates ownership, above that, we can just say, updates as listed. Okay, so basically we can just do this. All right, and basically just say const result equals await escrow is listed 1, and then expect result to be equal to true. All right, so it updates it as listed. Okay, next we're going to store some other values inside the smart contract. Basically, we're going to store the purchase price, the escrow amount, and the buyer ID. And we're going to store those inside of a mapping, just like we did here, because we want to do this on a per NFT basis. Okay, so essentially, we're going to create some more mappings like this. We're going to say purchase price, escrow amount, and buyer. So purchase price can be the amount of cryptocurrency and ether that it cost to buy the house. So the UN256 is the ID of the NFT. The price is going to be the price of the home. The ID of the NFT and the escrow amount and the ID of the NFT and then the address of the buyer. Okay. And so now what we're going to do is put all this here. We're going to basically say purchase price, NFT ID equals purchase price. Okay, we're going to pass that in here. That'll be UN256. Okay, we're also going to pass in a buyer. All right, and then also an escrow amount. Okay, and we're going to break this up in multiple lines here. Okay, so we're going to do this. All right. And then we're going to save those inside of here. Save the purchase price like that. We're going to add the escrow amount like this. And then we're going to save the buyer like this. Okay. And now we can check for those inside of here. All right. So we can check that it returns the buyer like this. All right. Returns the buyer like this. Okay. Returns the purchase price like this. And finally, it returns the escrow amount like this. All right, so what we're going to do here, I'll just pause the video and in a still frame if you want to make sure that that's all correct inside your code editor. All right, let's just run the test first, make sure they pass before you start doing that. Okay, all right, so we got a little issue. Let's just save this really quickly. All right, so I forgot to pass in the new arguments here. So whenever we list the property, we want to add some more stuff here at the top. Okay, so basically, whatever we call lists, we want to add also the buyer address. Okay, and then the tokens. All right, 10. And then tokens, 5. Okay. So tokens, what that does is it takes we're going to say basically it costs 10 ether, okay, to list the property. And we have this tokens helper here, all right, which basically takes the value and converts it to ether for the smart contract. And same thing for the escrow amount. All right. So now I'm going to run the test again, make sure it passes. All right, they passed. So now if you want to pause the video, make sure that this all looks correct, then you can do that now. Okay, so one final thing I want to do on the escrow list function essentially is make sure that only the property owner can do this, okay? Because you don't really want some random person to list the property, okay? So inside of here, what we're going to do is basically create a modifier, okay? Basically what we can do is put this inside of here at the top. We can create this and call a modifier here. And we can apply this to our function and say modifier only seller and require the message.sender is equal to seller. So only seller can call this method. And then we can add this modifier to it like this. Say only seller. And we also make this function payable so that they can send in, Ether with this function if they would desire. Okay, awesome. So now let's rerun the test, make sure it still passes. If you want to write a specific test to check for this, that only the owner can call this function, only seller, you could do that. I'm not going to do it for now, just for the sake of time. But now we have our basic listing functionality finished. All right, so now that we've listed the property right here, we need to go through the rest of the process in the life cycle, like buyer deposits earnest money. We update like an appraisal, inspection, okay, appraisal, inspection, lender approval, like lender adding funds to the contract, okay, transferring the ownership and the seller getting paid. That's the whole life cycle here. At least we're modeling that way, okay. So next, what I'm going to do essentially is create a function to deposit earnest money into the smart contract, and that's going to be from the buyer's perspective, okay. So basically, what we're going to do is have a way to deposit that. Okay, so basically, inside of after listing, we're going to minimize this. Actually, go to the contract first, and we'll create a function inside of here. It's just called deposit earnest. Okay, so what we're going to do, I'm just going to go ahead and add it like this. Okay. So basically we say put under contract, basically only buyer can do this. We get a payable escrow function. So we have this function called deposit earnest. We'll give it one argument to UNT56 of the NFT ID that's going for sale. Public payable, so they can send in Ether with the transaction, and we'll make sure the only buyer can do this. Okay, so we need to add in a modifier for only buyer with the NFT ID. All right. So basically we can go here at the top of our only seller, and then create our, this, and say only buyer, all right, and pass in an NFT ID. Say message.sender needs to be the same as the buyer of the NFT. Okay, so again, we store the buyers. We can read out this buyer mapping right here, and then the NFT ID, and make sure it's the same as message sender, who's the person calling the function, all right. So public payable only buyer, and then require message value is greater than or equal to the NFT ID, the escrow amount. All right. So basically, essentially the escrow amount is the amount that you have to put in for escrow for the buyer to, get skin in the game for the transaction. Sort of like a down payment in this case, sort of like earnest money. We're kind of blending those two concepts together. So if you're familiar with real estate, this isn't going to be like an airtight strategy here. We're just kind of modeling how you could do this with blockchain. So anyways, they're going to put some, down payment, earnest money, whatever you want to call it. I know there's different things, like I was saying before, but we're just kind of lumping those together as the same concept, even though they are different in the real world for the sake of this tutorial. So anyways, message value is the amount of Ether that gets sent in with the transaction, and we just want to make sure that's greater than or equal to the required escrow amount to put the property under contract. Okay. So, Well, let's just see here. That's what we're going to do here. We got everything that's required. So basically what they're going to do is send Ether just directly to the contract whenever that happens. And we want to make sure that it's the correct amount, and that Ether amount's going to get stored in the contract during this process. So basically, the buyer does that. They're going to send their down payment directly to the escrow contract, and the real estate NFT is owned by this. Now the buyer's funds for the escrow amount is owned by the contract as well. And then what's going to happen is the lender will be able to add their funds to this contract later, and whenever the property is actually sold, the sale proceeds will go to the seller, and the NFT will go to the buyer, and this real estate contract, escrow contract, facilitates that entire transaction. So now we deposited earnest money. Let's go actually do that in the tests. Okay, so we can write, instead of describe listing, we can say describe deposits. Okay, and then inside of here, we can say it updates contract balance. Okay, and then we say async okay, and then what we're going to do is we're going to say const transaction equals await escrow connect buyer. Okay, deposit earnest value 1. And then we'll say the metadata of the value is tokens 5. That's the actual escrow amount. We'll say await transaction wait. All right. And then we'll also say we're going to wait for it and check the balance. Say const result equals escrow get balance. And then that's going to actually get the balance of the Ether balance of the contract. And at this point, that should now be equal to 5 Ether, okay, that we deposited here. So save that, run the tests. Okay, so escrow get balance is not a function. Let's actually implement that. So on the contract at the bottom, what we're going to do is create a special function that helps us get the current Ether balance really quickly. So we can write it in our tests. So basically, we're going to do a couple things. We're going to do this. We're going to do get balance, all right, which essentially is just going to be a function, okay? And it's going to be public view. It's going to return UN256. And what it's going to do is just say return address this balance. So this address, this is the address of the current smart contract, and dot balance will just give you the Ether balance, and we can call this get balance function to just quickly return this. While we're here, let's also implement this receive function. Okay, so this is what's going to let the smart contract actually receive Ether. So like with the lender, for example, could send funds to the smart contract and increase the balance. You need this in order to accept Ether to the contract. Okay, so we'll go ahead and do those same two things while we're here. Let's rerun the test, make sure it still passes. And boom, there you go. Awesome. All right, so now we've got the ability for the buyer to deposit the earnest money or the down payment, depending on how you want to think about that. Okay. So now we want to talk about the actual, inspection, right? The appraisal type process. Okay. So what we're going to do is basically model the inspection. Okay. Property inspector wants to sign off that the property is okay and passes inspection before this can happen. So what we're going to do is essentially create a mapping for the inspection status, okay, at the top. So we have, just below the buyer, we're going to create a mapping called inspection passed. So that's going to have a key value pair. Essentially, like the UN256 can be the property ID, and then Boolean buys me true or false whether the inspection is passed. By default, it's going to be false because that's what mappings default to. So we can create a function to update it though, okay? And then we can basically do that like this. Basically, we'll just say, actually, let's do it up here. Update inspection status, that'd be a function. Okay, we'll give it NFT ID and then a Boolean true or false on whether it's passed. Be a public, only the inspector can call this, and basically we'll take that inspection pass mapping, pass in the NFT ID here, and we'll just pass in the value whether it's passed or not. Now, we only want the inspector to call this function, so we need to make an only inspector modifier. Okay, so at the very top, we'll basically just say below only seller, we'll say only inspector. Okay, message.sender is going to equal to the inspector address, which we saved here. Only inspector can call this function, and we apply that to the function right here. Okay. All right, so now let's write a test for that. We'll go here. All right, and after deposits, we'll copy that and look for inspection. So we'll say deposits. All right, we'll say inspection. And basically, instead of this, we'll do this. Const transaction equals await escrow connect inspector. Update inspection status 1 is true. All right, we'll wait for that transaction to finish. Do await transaction wait. And then we'll just say const results equals escrow inspection passed 1. And we expect that value to equal true. All right, so let's save that. Let's go to our terminal, run the tests. Okay, so we got a little issue here. Unexpected end of input in the thing. So it's because we chopped this off. All right, save that. All right, there you go, it passes. So we can do deposits and it updates the contract balance for the inspection. So I think I need to change this, updates inspection status. Save that. Yeah, awesome. There we go. Okay, so now I want to do one final thing before we actually facilitate selling the property. Okay. We want to have basically an approval process. So like, you know, if we want an inspector to sign off on the sale, an appraiser, a lender to just basically say, yeah, we approve the sale. We want to have a special function for that. So essentially what we're going to do is create a mapping called approval. All right, but it's going to be a nested mapping. So we can add it here. So we'll say mapping, the key of the NFT. All right, and then we're going to say the approval. So you can put a mapping inside of a mapping. And so this is going to be the mapping of the address of the person who approved it and whether that's true or false. So we do this on a per NFT basis. So we pass in the ID of the NFT. That returns a mapping, okay, of the address that, you know, of the person who's approving and then whether it's true or false. All right. So we can create a function to update that mapping like this. We'll just say approve sale. All right. So we'll say approve sale, pass in the NFT ID and message.sender will be the person who calls this. And then we'll just set it to true. And we can require this approval whenever we do the sale, which we'll see here in a second. But I want to go ahead and just test this out. All right. So then we'll go to describe inspection. We'll say describe approval. I'll say updates approval status. And then for this, we'll take this out. And then we'll replace this with this. Oops. Basically, we'll say let transaction equals await escrow connect buyer approve sale. And we can do the same thing for the seller. All right, basically, we can just do this. Do it 3 times. And then we'll say for the seller. And then also the lender. And we can check all those. Okay. So we can just say expect, you know, await escrow approval 1 for the buyer address to be equal to true, that the buyer's actually done it. Same thing for the seller. And then same thing for the lender. All right, so let's save that, go back to our terminal, run the test. Okay, so I've done let multiple times here, so that's not gonna work. All right, so approval, that updates the value there. Okay, so now we've done pretty much all that we need to do, with one final exception. We need to actually facilitate the sale of the property. So basically, we've added the ability to list the property. We had the ability to deposit earnest money, to do an inspection. We had the ability for approval for the lender to approve it. Now we need to go for, you know, basically like the lender sending the funds over and transferring the ownership so that the NFT goes to the buyer and the funds go to the seller. Okay. So we're going to do all that inside the contract with one final function like this. All right, basically we're going to go inside of here and then create a function called finalize sale. All right, this will be UN256, NFT ID, public. Okay, and so what do we want this function to do? Well, we want it to require the inspection status. Okay, you could add more items here like appraisal, etc., etc. Require the sale to be authorized. Okay, require the funds to be the correct amount. Transfer the NFT to the buyer and transfer funds to the seller. Okay, so we can require the inspection status like this. Basically, we can just say, require inspection passed NFT ID. Again, we're, doing that here, right? And then only the inspector can call this. Okay, we want to require that the approval from multiple parties. Basically, we're going to require that the buyer has approved this transaction. So we can require approval, NFT ID, then the buyer, okay, of the NFT ID. We want to require the approval of the seller. So we can say require approval, NFT ID, seller address, and then approval of the lender. So we can say require approval, NFT, lender. And then finally, we want to make sure that this contract is fully funded. So basically, we can do that like this. We can get the address, this, dot balance, all right, is greater than or equal to the purchase price, all right, of the NFT. All right. So that's basically going to make sure that all the funds have been sent to this contract, and we can require that. All right. And then that's going to check that all this stuff has happened before it will actually, do the transaction. So we're going to do more stuff inside of there, but let's actually make sure all this stuff happens before we do things like, transfer the NFT to the buyer and transfer the funds to the seller. Okay. So inside the escrow.js, let's do that. All right. I'll take a little more time on this one. Be very detailed. Say describe sale. Okay. And then we'll say async. And then inside of here, we can use it before each function, and we're going to go through all these steps. Okay. So the first thing we're going to do is go through this deposit earnest feature first. Okay. So we'll say let transaction equals await escrow connect buyer deposit earnest. Okay. We'll say value 5 tokens. All right. So, let's see here. That's going to make sure that we got the earnest deposit. That'll help us satisfy the condition of the balance. Okay. The next, we're going to update the inspection status. All right. So like transaction await escrow connect inspector. Update inspection status 1 is true. All right. We're going to approve the sale from the buyer like this. All right. We're going to say escrow connect buyer approve sale 1. All right. Then do await transaction wait. All right. That's going to satisfy this. We'll do it from the seller and then the lender. Okay. And then we'll say, let's just do here. We'll do connect seller, approve sale. All right. And we'll also do same thing for the lender. Lender, approve sale. All right. So that's going to check off all these boxes. All right. Now, finally, what we want to do is, essentially send, more money to this smart contract from the lender, all right, to fund the deal. Okay. And then essentially what we're going to do is we're going to send the transaction from the lender like this. We'll do await lender send transaction. We'll say to the escrow address. The value is 5 tokens. So now we have deposited 5, and then we'll add, 5 here for the entire purchase price. And then finally, we'll finalize the sale like this. Say transaction equals await escrow connect seller finalize sale, and we'll pass in the NFT ID 1 and wait for that to finish. And now we'll check to see what happens. Okay, so we'll just say, it, just works. Okay, we'll change this in a second. But let's just run this, make sure the before function actually works properly and that we're satisfying those conditions. Okay, let's save that, go to our terminal, npx hardhat test. All right, so it works, so quote unquote. So really what we're doing is just putting these require statements, make sure that the property is going through all the proper conditions, that it's got all the inspections, it's got all the approval, and then we mimic those inside of this process here. Now we just say it works. What now we want to do is actually check for other behavior. So what we want to do is say that, on our diagram here, that it actually, transfers the ownership of the NFT to the buyer and it gives the funds to the seller. So how can we do that? Well, inside of our real estate contract, we'll essentially go inside of here and we'll say, we'll basically send the Ether to the seller. So we'll say payable seller, and we'll say call. So call is a function that we can use to send any message we want to that address, but we'll use to send Ether in this case. We'll say value address this how much balance, and then we'll do it like this. Okay, and then we'll say bool success. All right, this is kind of a long-winded way of just transferring Ether from the smart contract to the seller. Okay, but it will return a success value, which we want to check. We'll say require success. All right, so that's going to send Ether to the seller. Okay, so we can check for that. Basically, we can just say check. We can just basically check that the escrow balance is now 0. So we'll say updates the balance, expect escrow balance to be equal to 0. All right. And then now what we want to do is actually transfer the NFT ownership to the buyer. So we'll do it like this. We did that with IERC20 transfer from, so we can literally just copy this same line here, okay? And then paste it down here, but let's kind of change the operation. So instead of doing it from here, the NFT is going to own it. All right, I'll take off this comment. Or the escrow is going to own it. So we'll just say address this, transfer from address this. We don't require any approval because the contract already owns it. And then we're sending it to the buyer. All right. And then let's go ahead and update that in the tests to essentially check that. Say it updates the ownership. All right. Let's say basically expect real estate owner of 1 now to be the buyer address, because after the sale, it transfers the NFT ownership to the buyer. All right, so that works. Awesome. So that should be pretty much it for the behavior in the test that we want to check for. There's a couple of things I want to do in the contract before we wrap up here. Basically, we want to now say that the NFT is no longer listed. All right, so right here, we'll just say is listed, NFT ID is false. Okay, but then the finalizing should take place. We also want to go ahead and add some basic behavior for canceling the transaction. Okay, so I'm not gonna really code this out in depth and not run a bunch of tests against it. You can do that for an exercise if you want to, but you want to handle cases where a sale gets canceled. Okay, so basically, like if inspection status is not approved, you could refund the transaction or sell it, send it to the seller. Basically the stuff like that, right? And you could add your own custom logic to this. And if you want to do that in tests, you definitely can. But I'm just going to add these here so to get you some ideas going for you. And I'm going to move this code to the bottom here. Okay, just so we're a little more organized. All right, then I'm going to run the test again, make sure everything still passes. All right, and there we go. All right, so now that we have successfully completed the smart contracts and written tests for them, now what we want to do is actually put the smart contracts on a local blockchain. So what's cool is Hardhat gives us a way to run a blockchain on our computer without having to talk to the internet, okay? So basically we can just say npx Hardhat node. All right, what that's going to do is start a local Hardhat blockchain on our account. on our computer. And that's going to give us these, 20 accounts with 10,000 fake Ether inside of them. So when we were running our tests before, essentially that's what Hardhat was doing behind the scenes every time we started our tests. But we didn't have to have this blockchain running, which is pretty nice. But now that we're actually going to put the smart contracts on this local blockchain so we can start building out our website, we actually want to have a blockchain running, and that's exactly what this npx hardhat node command does. So now what we want to do is create a special script that takes these smart contracts that we created and takes them off of our computer and then puts them on our local blockchain. So we can do that with scripts inside of Hardhat. If you go to this Hardhat, so this file browser over here, you can look at this scripts directory. You can see deploy.js inside of here. So this is a boilerplate script that you can run inside of Hardhat, and we can put all the code for it inside this main function. And this is where we're actually going to take the contracts off our computer and deploy them to the blockchain. So let's go ahead and do that right now. Inside of here, what we're going to do is we're going to do something kind of similar from our test. Remember inside of our tests, we did this, get signers from ethers, buyer, seller, lender, inspector. We're basically going to do that again inside of here. So we're going to paste that in here, set up accounts. All right. So buyer, seller, inspector, lender, do ethers, get signers. Again, we have access to ethers inside of here because we're using Hardhat. All right, and now what we want to do is basically get the real estate contract factory like we did inside the test. So const real estate equals wait ethers get contract factory real estate. All right, that's literally what we did here. Right, basically we can just even copy the same thing and then paste it. But we'll say const real estate, lowercase real estate. All right. And then now we want to get, wait for it to actually deploy for real. So we'll say await real estate.deployed. And now what we want to do is actually mint some NFTs. So, I've got the metadata for those here. Inside the metadata directory, you can see one.json. These are already uploaded to IPFS for you. So you don't have to upload this on IPFS. Again, you can just copy these links. You can see them right here, right? You can see this. All right, I've got this link posted in here, and you can see that it's, for one.json, you can change this to two.json, which would be the ID of the NFT here. Change it to .3. Okay, so I've already uploaded these for you, and so I don't want to reinvent the wheel for you, make this a little bit easier, but these are already on IPFS, so we can just add them to our real NFTs whenever we deploy them, okay? So we're going to go ahead and log this to console. We'll say, deployed real estate here. All right. And then now we're going to say we're going to mint 3 properties. So we're going to do this inside of a for loop. Okay. So for loop in JavaScript just lets you loop through a set of numbers and do something in that number of times. So we're going to say transaction equals await real estate connect seller, which we pulled out here, and then mint. And what we're going to do is paste in the IPFS URL, all right? But then we're going to basically take the I value, which is the current number that we're iterating over into this for loop. We're going to add 1 to it, and that's going to be the NFT ID. So basically, if we do that for 3, so JSON 1, 2, 3, ID 1, 2, 3, you can grab this IPFS URL if you want to from the final code solution, but basically you can, go to IPFS.io and then put this into your browser and then do 1.json and it'll pull up the metadata. You can see if you put in your browser and do 2.json, it'll give you the metadata for NFT number 2. Same thing for NFT number 3 because we've already uploaded them for you. Okay. So we'll mint 3 NFTs. All right, and then we're going to just deploy the escrow contract like this. Okay, so we'll say const escrow equals await ethers get contract factory, capital E escrow. Then we'll say const lowercase escrow equals await escrow.deploy. Okay, real estate.address, seller.address, inspector.address, lender.address, and then get the deployed contract. Okay, and then we're going to approve the properties from the seller. So just like we did the for loop here, we're going to add a for loop here that basically just says let transaction equals await real estate connect seller, approve escrow address, and then the value of each property. So 1, 2, 3. All right. And then finally, we're going to list the properties like this. We're going to say transaction equals await escrow connect seller list property 1, buyer address tokens 20, tokens 10. And then we'll do that for 2 more like this. We'll just say seller list 2, buyer address tokens 15, tokens 5, list 3, buyer address tokens 10, tokens 5 for these different amounts. And then finally, we'll just say it's finished. Okay. So I know we went that kind of quickly, but if you want to study this script even more, you can check out the final code solution and look over that a little more slowly. I just want to go ahead and move on to the front end part, but this is required to get the contracts off of our computer onto our blockchain. And it's basically the same thing we did right here, okay, with a little bit of extra steps. Okay, so let's save that. Let's go ahead and give it a whirl. Let's go to our terminal here and then make sure our blockchain's running. And then a new tab, we're going to say npx hardhat run scripts / deploy.js. We're going to say -- network localhost. All right. So I think I misspelled Hardhat. I do that all the time. Hardhat to Hardhat. Try that again. All right, so tokens is not defined. Let's just do that. We need a tokens function here. So let's copy that from our project. We need to add it here. All right. Time. All right. Awesome. So it worked. So I'm gonna reset this again. I'm gonna restart my Hardhat node just to make sure I didn't do anything when I messed the script up. So I'm gonna clear all this out, run it one more time. So npx hardhat run scripts deploy.js -- network localhost. All right, now it's minting 3 properties is finished. You can see all the transactions here. Here is the contract. Okay, here's the mint, escrow, approve, lists. So that was finished. Okay, so now you can see the deployed real estate contract is here. Okay, so now that we have compiled those and deployed them, I want to show you that, Hardhat has put your artifacts inside of here, your contracts, escrow.sol. It has an ABI, okay, like this. And then also the same thing for real estate. You've got an ABI inside of here. You've also got your addresses saved. So what I want to do is go ahead and update some of this for our front end before we start building out the front end application. So basically, if you go into our source directory, this is going to be for our client-side application we're going to use next. We're going to make sure those ABIs are inside of there. Okay, so this is going to be the exact ABIs for the smart contracts for the escrow. Again, it's the exact same ABI as is listed inside of this file. And same thing for real estate. So basically, we're going to create a React app in the next section. So if we need to make sure that our ABIs are inside of there. If you modify your code in any way, you want to update your ABIs from this directory. Again, this artifacts directory, contracts, real estate.json, basically taking this ABI and copying it and putting it inside of this ABI right here. All right. Same thing for escrow, right? So the other thing is we have this config.json here. All right. So inside of our source directory, we have the addresses for the smart contracts that are deployed to Hardhat. Okay. So the nice thing about Hardhat is it's going to give you the same contract addresses every single time. So you shouldn't have to update this. Okay. So you can see this right here. That's the same address here. And then you could log the escrow address if you want to as well. You could just go to your deploy script and then say, you could do this here and basically just say, deployed escrow contract at escrow address. All right, and let's do a teardown exercise. Let's restart the node, npx hardhat node. All right, and then let's redeploy the contracts. Oh, I misspelled that. Let's see here. All right. All right, so deployed a real estate contract here and an escrow contract here. So this should be A6E0 and 0FC9. All right, let's go to our config file. Let's do it again. Let's restart. I think it's because we already ran this. Hold on. Got a fresh node. Let's do it one more time. Oh, sorry, that's this npx hardhat run scripts deploy. All right, yeah, AA3. All right, and then F0512, F0512. All right, so that's the whole idea. You want to make sure that the real estate address here is here, and then the same escrow contract that's here is here, because we need to save all this stuff in our front-end application so we can talk to those smart contracts whenever we start creating out the React application in the next section. So let's go ahead and do that. All right, so now what we're going to do is go ahead and start building out the client-side application. Okay, so the first thing we want to do is go ahead and open up a new terminal tab here. All right, make sure your blockchain node's running. All right, make sure you deployed your contracts like we did in the last section. All right, but now we're going to start our web server with npm run start. Okay, and I've already got this running here, but this is the old copy, so this should reboot. You should have a new browser open automatically. All right, and then you should be able to see your website there. So this will take us just a second, but boom, there you go. You should see this white page pop up. This says welcome to Millo. All right, that's our Zillow clone here. All right, and you'll see all these kind of linter warnings inside of there. That's fine. That's because we have some boilerplate code. All right, so what we're gonna do is keep that running, keep our blockchain running. We're gonna open this in our text editor. Okay. And we're going to go to our source directory, and this is where all of our front-end files are going to live. So we have a React application inside of here. Okay, we've got this app.js file. Okay, this is some boilerplate code for the React app. Okay, we've got some libraries imported up here, like ethers. We've got some React hooks imported, like use effect and use state. We've got these other components in the components directory. We've got a placeholder for the home. For navigation and search, we'll dig into that. We got the ABIs for our smart contracts. Okay, the real estate ABI is here. All right, and the escrow ABI is here, and then our config.json file right here, which has the smart contract addresses that are deployed to the blockchain. Okay, and so we can see all that inside of our app.js. The app.js file is mounted inside of index.js right here. And we're also importing our CSS file, okay, which we wrote right here. So basically, we've already got some CSS preloaded. We don't want to spend a ton of time focusing on CSS in this tutorial. So I've gone ahead and just added the CSS for you so you don't have to write it from scratch, okay? Again, I just don't want to spend a ton of time on CSS. I'd rather focus on the blockchain side of things. So we've already got the CSS imported for you. And now we can basically go inside here at app.js and start editing things. So you can just edit this and see how it works. So you can just add an exclamation point here at the end of welcome to Millo, exclamation point. All right. And you can see our changes were automatically detected here. So now what we want to do is also configure MetaMask. Okay. So what I'm going to do is go to MetaMask and make sure that's installed and go to add a network here. And then you want to make sure that you add the Hardhat network. You can call it Hardhat. Okay, you can do your localhost address. All right, you can literally copy this from Hardhat and put it in here. Okay, it's already in use, so it won't work. Chain ID is going to be, let's just see here. Oh, it's in the project. Let me find it. The chain ID is going to be this. You can see the Hardhat chain ID inside your config.json, so just copy that. Okay, go back to your MetaMask here, add it here. All right, currency symbol is ETH, and block explorer, you can just leave blank. Again, I've already done this, so it's not gonna let me save it because I've got a conflict here, but just click save, okay? That should take you back to your MetaMask, okay? And then you should be able to see that new network Hardhat in your dropdown. Just go ahead and select it, and you should be connected to the blockchain. Now, let's talk about how to import your accounts. So you can go here to Hardhat, all right, where you started it up. You can see these errors here. That's okay. Go find your accounts. And what I'm going to do is I'm going to import them one by one. So I'm going to take this private key, okay? I'm going to copy it, and I'm going to go to my MetaMask here. I'm going to go to import account, all right? And I'm going to paste in the private key, click import. It's already done it All right, so I've already done it. It's going to give me an error, but if you haven't, it'll import it. And you should see it here. Now you can also go to your settings and then let's do this. Account details, you can rename it. I've renamed mine to Hardhat 0 because it's the first Hardhat account in the list, right? It's called account 0. So I call it Hardhat number 0, all right? And then what I recommend, you're gonna need to use multiple accounts in this tutorial. So go ahead and do this for the first 5 accounts on the list, 0, 1, 2, 3, 4. That's 5 different accounts. And whenever you've done that, we can look for like Hardhat. I've got 0, 1, 2, 3, 4, 5 even. So maybe go ahead and do 0 through 5. And you'll see all those accounts are inside of there, and you can switch between them, and you can see the Ether balance in each of them. Okay. So now you got your project connected to the blockchain. You've got your Hardhat accounts installed. Let's go ahead and start coding out that front end. All right, so now let's go ahead and connect our project to the blockchain. So what I'm going to do is create a new function inside of my component here inside of React called load blockchain data. So let's say const load blockchain data. All right, that's going to be an asynchronous function. Okay. And inside of here, what we're going to do is we're going to go ahead and pull our connection from MetaMask. So MetaMask injects something into our browser called window.ethereum. All right, so you can even visualize that here. Let's see here, we got a problem. Let's just take this out for a second. All right, let's open our developer console so you can do inspect element or inspect, and you can see this pop up down here. You can click on the console tab, okay, and that will give you a JavaScript console. So we can see this global variable inside JavaScript called window, all right, and you can do window.ethereum, okay, and this essentially is our connection to the Ethereum blockchain that's injected by MetaMask. So window.ethereum in this case is the connection to the Hardhat blockchain that we have running right here, okay. So you want to connect to this so that we can pull in the smart contracts and start creating a Dapp. All right. So inside of here, let's go into our load blockchain data here. Uncomment that again. So basically, need to change this. All right. And what we want to do, let's just save this, see if we can look up the error. So really what we need to do here is just assign this. So essentially what we're going to do is create something called the Ethers provider. So again, Ethers is the library that connects our project to the blockchain. So by default, like our app is not going to talk to the blockchain on its own. That's what we need Ethers.js for. So we're pulling in Ethers at the top. And in order to create a connection to the blockchain, we can use something called the Ethers provider. So we do that like this. We just say const provider equals new Ethers providers Web3 provider, and we pass in this window.ethereum right here. Okay, so we can do that, and we can say console.log provider. Okay, and we can see it renders, and now okay, that's not working just yet. Let's just do that. That's okay. Okay, so first of all, we're loading the blockchain data. We're not calling it yet. Okay, so essentially, how do we do that? Well, with React, we're using a functional component here, and we can use something called a React hook, all right, which is going to let us do that. So we're going to use the use effect hook, okay, which is essentially going to get called whenever this component renders to the page. So we can say use effect, all right, and then pass in a function like this. And inside of here, we'll call load blockchain data, because here we just defined the function. We're not calling it yet. And then essentially we want to do this at the end. Pass in an empty array. That's going to detect any changes, but we don't care about that. So let's just save it. And then now you can see that we're logging the Web3 provider to the console. And so this is going to give us everything we need in Ethers to talk directly to the blockchain. Awesome. So with that, we can do things like get the account from our MetaMask. So we can get accounts like this. Basically, we can say const accounts equals wait window.ethereum request. We can say method eth request accounts. All right. And we can essentially log those to the console. So console log accounts. All right. And then now we can see our account from MetaMask right here is logged to the console. All right. So great. Now we're cooking with fire. So what we want to do is basically save this account to the component state. Now let me talk really quickly about React component state. Okay, so React, uses components to organize our code. All right, so this here is a React component. We have some other components inside of here like home, navigation, and search. We'll get to those in a minute. But this is our main component. Basically, a component is just a place where you can, reorganize and reuse code and render them onto the page. But our components also have a state, okay? So a state is really just like, kind of like a little database inside of each component. So for example, you can see like this component here is a to-do list, and it has items on it, like item 1, item 2, item 3. All right, so where do those items go in this to-do list? Well, they go inside the component state. It's like a little database that exists inside of this component. Now, this example here is with a class-based component in React, but we're using functional components. So just like we did the use effect hook here, we can do a use state hook, which is here, and we can read and write from the React component state like this. So essentially we can do a component like this. We can do this. We can create functions for reading the account and setting the account like this. So we can say account and then set account equals use state null. So what it's going to do, it's going to fetch the component state and give us two different functions. One to read the account from the state and one to set the account to the state. And by default, we're going to say if the account doesn't exist, just return the null value. Okay. So then essentially we can write it to the state like this. We can do set account. All right, and say accounts is 0. Since it's an array, we can get the first item. And then we can do console log, account. Okay, and that'll actually read it from the state. So now we can prove that we can read it and write it from the state. So let's kill that. Back to our tab here. And now we can see, well, hold on a second. Let's do that. Let's just log it as account 0 first. All right. We'll read it in a different context in a minute. All right, good enough for now. Good enough for now. Well, let's actually create a component where we can use this account. So now we'll show you how to render another component onto the page and then use this information inside of there. So what we're going to do is take this navigation.js and build this out to actually handle the component and actually render the account on the page. So inside navigation, what we're going to do is we're going to sketch out some user interface here. All right. So basically, you can grab this in the final code solution below if you want to, but I'm just going to quickly sketch out some HTML inside of here. All right. So I've added some basic HTML for this navigation component. Okay. So we put a return inside of here for this function, and we've added a nav here. Okay. Inside there, there's an unordered list, UL. It's called nav links for buy, sell, rent. Okay. And then this div here that is the branding. So it's got the logo pulled in. We've got that here. We have Milo as a site title. And then we have this button here that's going to show the account. So let's go ahead and render that component onto the page. Then we'll pass in the real account in a second. Okay. So up here inside of inside the app.js, we're going to just below this div, we imported navigation right here. And so we're going to render it onto the page. We'll just say navigation, and we'll do a closing tag like this. All right. And let's go look at our page again. And then boom, there we go. We can see we've got buy, sell, rent. We've got Milo as a brand in the middle. And then this button with our account inside of it, but it's not the real account. So that's just a placeholder. Let's actually fetch the real account. So what we'll do, we'll take this account here that we have requested, and instead of doing it here inside load blockchain data, let's actually do it inside of our component, okay? So we're going to go to our navigation, and we're going to do this And instead of just doing it automatically, we're going to have a button that lets us, connect to the account. So what we're going to do is we're going to use this here, this account and set account. We're going to pass them in to the component like this. We'll say account equals account, and then set account like this. All right. And we're going to take all this out. All right. And then we're going to create a function called connect handler. And we're going to put it inside of here. And it's going to do the exact same thing. It's say accounts await window Ethereum request, get accounts. And we're going to set the account to the first account in the list. And then that's going to set it in the component state of the parent component. And we're going to pass it back in here with this account like this. All right. And whenever that finishes, we're going to render it onto the page. Now, we only want to do that if the account exists, and we want to have a button that calls this connect handler. So I'm going to take this out, and then I'm going to do this. Okay. So basically, this is going to be a conditional inside JavaScript that says if the account exists, show the account on the page, and let's truncate it. All right. We're just going to slice out the first few characters of it, use an ellipsis, and then do the last several characters of it. And but if it doesn't exist yet, we're going to let you connect to MetaMask. So you're going to click this button. All right. It's going to click the connect handler on click. And then it's going to load the account, save it to the component state here. It's going to pass it back down to the component, and it's going to show it on the page right here. Okay. So let's do that. Refresh the page, and then there's no account connected, but we have MetaMask installed, so we can just click connect, and boom, it will load the account, and you can see the first several characters of your account from MetaMask, just like they show you in the MetaMask UI with some dots in the middle, okay, and the last characters, and that matches the exact, format there. All right, so now that we have loaded the account into the Navbar, I want to do one more thing here, which is I want to change and update the page if you change your account inside MetaMask. That's one of the reasons we're storing the account here in the app level. So I'm going to do this inside local blockchain data. The last thing is going to be this. So we'll say window to Ethereum on accounts changed, okay, and pass in a function here. We're going to refetch the accounts just like we did, and then we're going to get the account and set account here, okay. So I'll pause that if you want to make sure that you've got the same code. All right, so basically you can see what that does is, we've connected, click connect. If we go to accounts inside of MetaMask, we go to Hardhat, hat1, and we click 1. All right, it'll automatically show the new account here. And then we can go back to our Hardhat 0. Okay, and then it will go back 226. Awesome. All right, so now that we are, done with the account section and the header, let's go ahead and look at our mock-up for our finished project. We've got this part done. Now let's go ahead and add this search bar inside of there. So that's gonna be pretty straightforward. We already have a search component inside of here. All right, so this search.js. So really, this is just a placeholder for now, okay? This is kind of just a proof of concept mock-up, so we're not really gonna do any searching, but it's just gonna make it look like Zillow, okay? So you could add searching features here if you wanted to, but for now, we're just gonna add the search bar like this. Basically, just below navigation, we're just gonna type in search. Oops, search. I'm gonna close that. Okay, save it. And then, boom, there you go. Now, if I close this, it'll actually format correctly. But if I, load up the page, it's gonna overlap. That's okay. We'll just do that for now. So now we've got this implemented. And then finally, let's go ahead and scaffold out this section where we just show the homes on the page, okay? We're gonna go here and just create this div cards section, or I'd say welcome to Milo. We can take out the exclamation point from earlier. Okay. Let's, instead of saying welcome to Milo, let's say homes for you. All right, we'll do a horizontal rule here. Okay. And then we're going to have a div here. Div class name equals cards. And then inside of here, we'll we'll just do this. We'll say div class name equals card. Okay. And then inside of here, we'll do a div that is the card image. Okay. Close that div. And inside of that, we'll do an actual image tag. Sorry. Okay. And then we'll just give it an alt home. Okay. Well, source, we'll just leave blank for now. And then we'll do a div. We'll say class name. It's going to equal card underscore info, 2 underscores. We'll give it a H4. And we'll just say, this will be the price. We'll say 1 ETH. We're going to hard code this. We'll change it later. Okay. Then we'll give it the attributes. Give it a paragraph tag. Okay. And then we'll give it a strong. Give it 3. And we'll just say, this would be like 1, 2, 3. And we'll do space, beds. Okay. And then bath. And then square feet. Okay. And then finally give it the address. We'll say 1, 2, 3, 4 Elm Street. All right. So that should be the placeholder. Okay, awesome. So we got one home there, just a placeholder. We could copy and paste this a couple times to show some homes there. But now we're getting a lot closer to our mock-up, okay? So we've got the nav bar here. We've got the search bar. We've got the placeholder for the homes section. Now let's actually wire up the smart contracts so we start listing the homes out on the page. All right, so now let's list the homes out on the page. What we're going to do is connect to the blockchain and get to the smart contracts and load them up into our app, okay? We've got the necessary pieces already. We've got the ABI. We've got the address from the config file. So let's connect to the blockchain like this. First of all, we want to, we've got the provider from Ethers. So we also want to create a hook to set the provider. So just above account, we can do provider and set provider as use state null. And we can say set provider and then pass in provider, okay? And then next we can get the network, const network. We want to tell it what network we're connected to. In this case, it's Hardhat. So that's the network ID that you see here inside your config file. So config here, this is the network ID. So different blockchain networks have different IDs, like the Ethereum mainnet's 1, like Arinkeby, I think is like 4, et cetera, et cetera. So Hardhat's that one, 33, whatever. So we get the network like this, await provider, get network, okay? And we want to save that, okay? And then use it, save as the variable. We'll use it when we read the contract. So we want to get basically we want to get the network because we're going to find where the contract's deployed with this config file. So this config.json's got our address. We want to fetch this based on this network. We can get the address for the real estate contract, okay? So, like the, basically we can read the config file already like this. So we can say like config, and then pass in network ID, .chain ID, okay? And then get the escrow address, the same thing for the NFT address. Okay, .real estate address. So these are the two addresses and we can console log those. You can just console log these so you can see that they're there. Let's just comment these out for a second. You can see that they're logged to the console. So I pulled those straight out of our config file. Those are our smart contract addresses that are deployed to the chain. Okay. So let's actually create, JavaScript versions of this with ethers.js. So we can do that with ethers like this. We can say new ethers dot contract, capital C. And we can pass in the address for real estate. So we'll just copy this, put it in here. We need the address. We need the smart contract ABI. Okay, so we have that right here from the real estate ABI. Again, we pulled this in from our ABIs right here, real estate.json. So we take this, we paste it here. And then finally, we give it the ethers provider, which we did here. Okay, and then we just say const escrow. No, this is real estate, excuse me. Okay, I'll move this over so you can see it. And now we're able to actually get that as a JavaScript version of the contract, so we can call its function. So the first thing we want to do is get the total supply of the homes. Okay, so we can do that like this. We can just say const total supply equals await real estate total supply, and then let's just go ahead and console log that. It's going to tell us how many homes are in existence. Okay, so you can see this number here. Let's just do toString. All right, so there's 3. There's 3 total homes that we can list. All right. And so now what we want to do is load the escrow contract. Okay, so we've got the real estate contract. Let's do a JavaScript version of the escrow contract. 2 smart contracts in this situation. So we'll do this, say const escrow. So ethers contract config network chain ID, this one, escrow address. And then we'll pull in the escrow ABI right here. Okay. And then this time we're actually going to save it to our state as well. So just below provider and set provider, we'll do escrow set escrow equals useState null. And then we'll load the escrow contract and do set escrow. Escrow. Okay. All right. So now we've loaded both smart contracts. Let's just go to our page and make sure everything's still working. Yep, we're good. Don't worry about this right now. It's still working. So now what we want to do is list out all the homes on the page. Okay. So we have loaded the real estate, loaded total supply. And what we want to do is basically store all the homes so we can list them out on a page right here. So basically we're going to say, const homes. We're going to load them into an array. All right. So because we stored, let's see, real estate. Because we basically have stored our NFTs inside of a mapping, we can't get them all. So we need to figure out how many there are and then loop through all the NFTs and fetch them out one by one. So we have the total supply, which we saved here. So basically we can say, we know there's 3 NFTs, ID of 1, 2, 3. So we can loop through those numbers 1, 2, 3 and fetch each NFT out individually and save them inside this array. So we're going to do that with a for loop inside JavaScript. So basically we're going to say for var I equal to 1. And then as long as it's less than or equal to total supply, we'll keep looping and then we'll increment by 1 each time after. So what we'll do is basically, we'll say const URI equals await real estate token URI. For I, this will be, number 1, the first time this runs, number 2, the second time it runs. We'll fetch the URI, okay? And then we'll get the metadata. So we'll get the response metadata from IPFS. And then we will push that into our homes array and we'll populate this for all the homes. And then finally, we'll set the homes with a useState hook, just like this. All right. And then we'll do set homes right here. Set homes, okay. And then now we can do console log homes to see if they've all been loaded. All right. So if I go back to the page, you can see here that there's an array, 3 different homes with all of the metadata. All right, so you can see here's home number 1, the address, got the attributes, got the description, luxury penthouse, heart of NYC, ID 1, IPFS, luxury penthouse, okay, et cetera, et cetera. All right, so we've actually successfully loaded this from the blockchain. So now what we want to do is loop through all these homes and put them on the page right here. So we've got all this loaded up. Let's take out the console log. All right. And down here, let's loop through them all. So underneath this cards, let's evaluate JavaScript inside of here with curly braces. So that's the cool thing about React is you can mix JavaScript and HTML in the same place. You can see we've done that here, but now we're going to evaluate JavaScript here. We're going to say homes.map. So map is a function inside JavaScript that lets us loop over the array. We're going to access each home like this, and then also the index, which is basically just the position inside the array. Okay. And we're going to render all this content onto the page. So we're going to take everything inside this card. Okay. Take that out and we're going to put it here. All right. And then we're going to essentially give each home a unique key. React requires that. So we'll say key equals index. All right. And now that's just going to show us 3 of these cards on the page with no data, no special data, but it's going to show 3 of them. All right, so let's kill this. Wait for it to load. It might take a second for it to load for you. Give it just 1 second here. All right, so we realized I made a mistake here. It's a subtle thing in JavaScript. We need to make this a parenthesis instead of a curly brace, because that's going to have an implicit return value. So let's just do that here. All right, so just convert that to a parenthesis and this to a closed parenthesis. So let's save that. Let's go back to our page here and then boom, there you go. Awesome. So now we actually see 3 different cards rendered onto the page. Yeah, I was saying wait, don't wait around forever. That was my mistake. Yeah, I just had to change that little thing in JavaScript, okay? So now let's actually fill in each of these homes individually to show the real home attributes. Like this is just hard-coded stuff here. But we are actually, rendering 3 homes. We just need to fill in all their data, okay? So let's go to the image. So for source, we can do home.image, all right? And then boom, there you go. We see 3 different pictures of the properties we want to buy here. Okay. We can do, for the price, let's do curly braces here and say home.attributes. And then we say 0.value. Okay. And then boom, there we go. Say 20 ETH, 15 ETH, 10 ETH. All right. So that's working. Let's do for beds, we can do this same type of thing. Let's just copy this, paste it here, and then let's say attributes 2 value. All right, now we see 2 beds. Same thing. Let's just copy this here. And we'll change this to 3 and then 4. All right, now we can see these as unique values. So 2 beds, 3 bath, 4 beds, 4 bath, 3 beds, 3 bath, and the square footage is unique for each one of them. Now, finally, let's get the address, okay? So we'll just take this out and do home.address. All right, so boom, now you can see the unique address for each one. Okay, so we are pretty much finished in terms of the initial layout. So you can see, here's the mock-up, here's this. We got one discrepancy here. We need to capitalize for you, so that it looks the same. For you. All right, so now it's looking the exact same as our mock-up. Slight sizing difference because this is a screenshot and this is a real website. Okay. But yeah, awesome. So now let's move on to actually finalizing the purchase and all that stuff. So what we're going to do is click on each of these properties. It's going to pull up a special tab for us to actually do the purchase. So let's go ahead and knock that out right now. All right, so now let's go ahead and work on purchasing the home. So the first thing we want to do is click on one of these homes, okay, and then have a pop-up that shows the home so we can go through the purchase, okay? So let's do that first. Let's click on a home, make a pop-up up here. So what we're going to do in order to make that happen is we're going to use an on-click handler. So inside of this card here, we're going to say on-click. Okay. And then we say equals this. And then we're going to do this. Say toggle prop. And then we'll give it the home. Okay. So this is not a function yet. Let's create it. So up here, we're going to say const toggle prop. And we'll pass in the home. All right. And then we're just going to say console log home for now. So let's just make sure it's talking to it. All right, let's click on a home and boom, it'll show us the home. So now what we want to do is actually have a special property inside of our a special state that tells us whether this is, open or not. So the first thing we're going to do is use a React hook, okay, to set the individual homes. We have set homes and homes here, but now we're going to do singular. So we're going to say home and then set home. All right. So what we're going to do here is basically just say set home, home. All right. And then we're going to have a toggle, which basically is going to toggle the component, whether it's open or not. And so we'll say, it's below home, we'll say toggle and set toggle, use state false. Okay. And inside of here, we're going to say, if toggle, question mark, say set toggle, false, otherwise set toggle, true. Okay. And then down here, what we're going to do is check to see if the toggle is active. So we'll say toggle, question mark, and this, and we'll just render home. Okay. And we already have this home component imported here. All right. And now you can see components home.js. We have a placeholder for the home right here. Okay. So let's go back here and we already got a problem here. That was my fault. I'll take this question mark away. That's my fault. I made a stupid mistake. All right, let's do that. And then let's close this and let's click on a home. And now we can see this overlay has popped up. All right. And a home should appear. Now it's not doing anything yet. That's okay. We can see our screen kind of goes dark. It actually is popping it up. We just haven't filled out any of the HTML inside this home component yet. All right. So you can see this home function accepts some different arguments, like the home itself, the ethers provider, the escrow contract, and the toggle prop. So let's go ahead and pass those down. All right. So right here, we'll just add those like this. We'll basically just say home, and then the lowercase home, and provider is provider, and account is account, and then escrow is escrow, and then toggle prop is toggle prop. Okay. And now those should be inside of our component. And so now what we want to do is start filling this thing out. All right, so now inside of here, let's start filling this out. First thing we're going to do is create a new div inside of here. Okay. We call it home details. All right. We're going to close this as well. It'll put all the content inside of here. So next, we're going to add basically an image for the home. So we'll do a div for home image. Again, this is going to pick up the CSS we've already written in that CSS file, so you don't spend much time writing CSS yourself. And we're just going to go ahead and add an image tag inside of here with the home.image. Oops, sorry, this. So we'll just do image, source home.image. So we got home here. Okay, so let's just save that. Go back to our thing. So toggle pop is not defined. Toggle prop, sorry. Okay, let me just fix that. So I think I called this prop. This should be pop. Sorry, everybody. Yeah, toggle pop up, basically. That's all I do. All right, so let's do that. Click on this, and now we can see we have a pop-up that's just got the home image right there. So now we can fill this out even more. Okay, let's go ahead and create a way to close it. All right. So down here, just below the home details, we're going to add this button that basically closes the pop-up. So basically we'll add a button down here like this. That basically just says, button toggle pop. It'll, once we click it, it'll make it go away. And we can have an image here that just says close. Okay. And actually, we want to put this inside the home details as well. Like this. All right, so now we see this X here. And click it and it goes away. Awesome. And that X is coming from this close, which is just an X that we've saved already inside the project, imported right here. Okay, let's keep going here. Let's figure out some more attributes. So below the home image, we can create a new tab, or new div, called Home Overview. All right, and then we can close that div. And inside of here, we can give it H1. We can give it the home name. So home.name, save that. Click on home. You can see luxury penthouse. That's working. Fill in some more details, like this. The home, just like we did on the home page. So we can give it a paragraph with some strong attributes, home attributes, 2, 3, 4, beds, bath, square feet. And then we can also give it the home address and a paragraph below that. And then just below that, we can give it the H2 for the ETH value. All right, so boom, there we go. We can see some description here. Luxury penthouse, 2 beds, 3 bath, 2,200 square feet, address, 20 ETH purchase price. Okay. Now we can let's give it a button to buy. Okay. So we're going to change this in a minute, but now we're just going to give it another div here. Right here, let's give it a div. We'll give this button. Okay. So this button will basically just be the buy button for the, home. Take out all this stuff. We're not going to do any on clicks yet. Okay. We'll just give it a basic button. All right. We're going to change this in a minute. So I'm going to give some space. That's obvious. We'll just give it a div, home buy. All right. You can say that. And then now you can see this buy button comes up where we'll click it and we'll actually do the purchase in MetaMask. Okay. And then we'll have a button here to contact agent, just like you'd see on Zillow or something. By contact agent. And then we'll give it a horizontal rule and another H2 for overview. And then we'll give it the home description like this. Home.description. And we'll give it another horizontal rule. And we'll give it like facts and features. Okay, we'll fill those in a second, but let's just take a look at what we're doing here. Yeah, it's starting to look better. Luxury penthouse, buy, contact agent, overview, luxury penthouse located in the heart of NYC, facts and features. Let's give it an owner list here. So let's say UL. And basically we'll map over each of the home attributes and add a list item like this. Okay. But basically we'll just do that in one go. We'll say home attributes, map, attribute index. We'll give it an LI, key index, strong attribute trait type, and then attribute value. That's from the NFT metadata. All right. Boom. There you go. Facts and features, purchase price, type of residence, condo, beds, bath, square feet, year built. Okay. All the metadata you want to see on a Zillow property. Okay. So you can click buy, contact agent, overview, all the details you want to know. Okay, so now we have successfully wired that up for each property. You can see how those values change for each one. Now let's actually facilitate the purchasing behavior. Okay, so now for the complicated part, we essentially want, the different accounts with their MetaMask to come here and approve the transaction. So like the buyer's going to click the buy button, right? But the lender can come in here and fund it on the same website. The inspector can, sign their approval on the same website, all in one place with their MetaMask wallet. So in order to do that, we want to contextually show a different button here based on who's connected, okay? So the first step in that process is fetching the different accounts from the smart contract to determine what we want to show you if you're the buyer, seller, lender, inspector, all that type of stuff. So let's go ahead and create a function to fetch those values from the blockchain. Okay, so above the return function, or return right here, we're going to do const fetch details. Okay. And inside of there, we're going to get the buyer. Okay. So we're going to get the buyer's address like this. Basically, we're going to say const buyer equals await escrow buyer home ID. And this will return the Ethereum address. Because again, we did that inside the smart contract. Let me just show you. You can see, we have the seller address, the inspector, the lender, and the buyer in the mapping here. Okay. So the buyer's listed inside that mapping. So essentially, we can just go here and do escrow buyer and then pass in the home ID, and it'll tell you the buyer address. Okay. And then we want to save that to their component state. So we'll say buyer, set buyer from use state. Okay. And also, we want to also store the lender. So we'll do that there. Lender, set lender, inspector, set inspector, and seller, and then set seller. Okay, and we'll populate those right now. So we'll do the same thing here. We'll basically, do the same thing for the seller. So we'll do buyer. Also, we need to set the buyer like this. So buyer, seller, set seller. And we'll do lender, set lender. And then we'll do inspector, set inspector, okay? And if you remember, we did all those in our deployment script here. So you can go to scripts, deploy, and you can see which account. So buyers, account 0, account 1, account 2, account 3. And we save all those here, okay? Let's go back to our site, refresh just to be double safe, and then no errors. Okay, nothing in the console. We have the same error from before. Don't worry about this. Code should be still working just fine. Okay, so another thing we want to do is we want to keep track of each of these people's actions. Okay, so basically we want to see if the buyer's actually bought. Okay, so what we're going to do is do like this for the buyer. We're going to say, const has bought, await escrow approval, home ID, and the buyer. And we want to set that value. So we're going to say at the top, say has bought. Okay. And then we're going to say set has bought right here. All right. And then we're going to do the same thing for the lending, same thing for inspection, and same thing for selling. Okay. So do that for here. Has lended, set has lended. And then has inspected, set has inspected. And then has sold, set has sold. All right. And then we'll update all those for after the seller. We'll say has sold equals await escrow approval, home ID, seller. And then has lended. Basically, we'll go here. Has lended, escrow approval, home ID, lender. And then inspector. All right. Has inspected, inspection passed, home ID, set inspection passed. Now, finally, we're going to fetch the homeowner so we can keep the status of that. Basically, going to do const fetch owner. All right. And inside of here, we're basically going to say const owner equals await escrow buyer and get it for the home ID. All right. And then we're also going to set the owner up here. Okay. So we'll have owner, set owner. And then we'll update the owner right here. Okay. And then one other safeguard condition we're going to do inside of here, basically, we want to make sure that the home is listed. All right. So we're going to return if that's the case. All right. And now finally, we want to call these two functions. So we've done fetch details and then fetch owner. We want to use effect. All right. And we want to call those two functions. Fetch details and fetch owner. And then we also want to detect is has sold changed, okay? Which is here. And if has sold changed, we want to fetch all this stuff over again. That's what this does. If this variable changes, then it'll recall these functions on use effect. All right, so now that we have loaded up all that information, we can show a different value here based on who's connected with MetaMask and what they should be doing in the transactions. Like if you're the lender, you can see like a lend button here, like approve and lend, approve inspection, all that type of stuff. So let's go ahead and make that contextual. All right, we'll go back to our back to our code here. And right here where we see this buy button and contact agent, okay, we'll do this, all right? So basically we're gonna evaluate JavaScript inside of here. We're gonna say owner. Oops, sorry, not oneer, owner, question mark. All right, and then we'll give this a conditional. So that'll be the first condition, second condition. All right, so we'll break this up in multiple lines. So if they're the owner, we'll do this. Otherwise, we'll do this, okay? So if they're the owner, we're gonna give it this div. All right, owned. Okay, and then basically we'll say, oops, sorry. Inside this div, we'll say, owned by this owner, right? We'll slice the address and display on the page. Okay. And then otherwise, in this other condition here, we're going to add a new div. Okay. And now we're going to see if the account is equal to the inspector, question mark. If that's the case, then we'll do this. I'm sorry. Okay. And we can do like, yes, if not. So if they're an inspector, we'll do this. All right. And then basically, otherwise we'll say, account equals lender, question mark. All right, and do a new condition here. All right. Oops, sorry. And then we can do another thing here and say account equals seller, question mark. And say, and if not, otherwise, we'll just do this condition. So now we can detect if it's the inspector, if it's the lender, if it's the seller, and everybody else will show, we'll show this buy button. So let's go ahead and take that buy button, and then let's put it inside of here. Okay. And then we'll put the contact agent here, take this out, get this div away. So just below this. Nest that inside of there. Okay. So if none of these accounts, we'll show the buy button. Now, if it's the inspector, okay, we want to have a button here that says approve inspection. Okay. If it's the lender, we'll say approve and lend. All right. If it's the seller, we'll say approve and sell. All right. So now let's go check our page, make sure nothing's broken. So account is not defined. Okay, so let's get the account here. So we need to pull it from up here. Basically, we need to make sure we're passing in the account here. So we'll do account at the top, component, home, provider, account, escrow, toggle, pop. And the same thing here, home, provider, account, escrow, toggle, pop. All right. So now let's go back to our page. So we misspelled account on line 98. Let's fix that. All right. And then now it should work. Okay. So now we can see that we have the buy button. Okay. So let's look at our deployment script. So the first count in the list is a buyer, so they should be able to buy the property. That's fine. Second account should be the list, should be the seller. All right. So if you go to MetaMask and then go to Hardhat 0 or Hardhat 1, click on that. You can see it changed to approve and sell. Hardhat 3 or Hardhat 2. We can now see approve inspection as the inspector, and then Hardhat 3, approve and lend. All right. Hardhat 4 is, let's connect, and then you can see it's buy. Okay. So, basically every single account that is listed, the button is now contextual. Okay, awesome. All right, so now what we want to do is click these buttons with each individual MetaMask account to process the transaction. So again, we have to go through this to essentially, do every single step in the real estate transaction. So I'll pull this up on my whiteboard here. Again, we need to basically act as multiple different accounts, essentially to fund the deal, approve the inspection, approve it as the buyer and the seller, and then, in the smart contract, actually facilitate the purchase and transfer of the funds and also the NFT for the real estate. So let's do that. Basically, we want to click a button for the inspector, click a button for the buyer, for the lender, click a button for the seller, okay, and then click a button for the buyer. So we want to create some functions up here. So just below this, I'm going to drop these in. So we'll do a buy handler, an inspection handler, a lend handler, and a sell handler, okay. So I'll stop my screen right there if you want to copy those down. And then now what we want to do is call each of those respectively, all right, down inside of the thing. So for this one, for the inspector, the button here, we want to say, on click, and we want to do inspect handler. I'm going to call that function. And also we want to disable this button if the inspection's already happened. So we'll say disabled. We'll say and has inspected. Okay, so we're going to use this in our state up here. Okay, so we've got that for each different property. So I'm going to copy these and put them on each of these. All right, we're going to change that. So for lender, we'll say lend handler. Lend handler, and then also has lended. And for sell handler, then has sold. And then inspect handler, or sell handler. Buy handler, my fault. And then has bought. So now when we click these things, they should be firing off the functions, okay? So now we need to actually wire these functions up to do each phase in the transaction. Okay. So for buying, what we're going to do is basically do all the calculations underneath the hood. Basically say const escrow amount equals await escrow amount, home ID. So we're going to see how much we need to do. And the buyer's basically going to deposit the earnest money directly into the contract and approve the transaction. So it'll be two transactions. So the first thing we want to do is get the signer, all right, from the buyer. Basically, signer equals await provider gets signer. All right, that's the current account we're connected with MetaMask. We'll let them deposit the earnest money first. Okay, so basically they deposit earnest like this. Transaction equals await escrow connect signer deposit earnest home ID, and the value in that transaction is going to be the escrow amount, which we fetch from the contract. They'll send that to the MetaMask wallet when we do the transaction wait, and then they'll call a second transaction, which is the approval step. So they'll approve the transaction, say await escrow connect signer approve sale, and then home ID transaction wait. All right, so I'm going to format this. I'll bump these over actually. All right. And then finally, we just want to set has bought to true so that it disables the button when they buy. Okay. So same thing for inspection handler. Basically, we're going to do a similar process. We're going to get the signer, which is the first account from MetaMask. Okay. All right. And we're going to update the status like this. Basically, we're going to say transaction equals await escrow connect signer update inspection status. And then we're going to set has inspected to true. All right. And then we're going to do the same thing for the lender. Basically, we're going to get the signer. Account signer equals await provider get signer. And they'll approve the transaction first. Okay. So just like we did the approval here, we'll say lender approves, transaction was await escrow connect signer approves sale. And then they're actually going to send in the funds for the funding the deal. Like this. Say we get the amount, lend amount is escrow purchase price minus the escrow amount. All right, so basically we say how much did the buyer put down and what's the home purchase price. We factor in the difference, and then they actually send Ether directly to the escrow contract with this amount. And we say set has lended true. All right. And then finally for the sell handler, I'll just pause that in case you want to see it. Hold on. All right. And then finally for the sell handler, we'll do a very similar process. We'll get the signer. The seller will approve the transaction. All right. And the seller will actually do the finalizing the sale. So they will actually facilitate the transferring of the NFT to the owner and new owner, and then they will get the funds into their wallet, and we'll say it has sold to true. Okay, so I'll pause that if you want to see that as well. All right, so let's go through it. All right. So right now, we can see, let's go ahead and change the owner. So let's go look at our accounts in MetaMask, and let's look at the deploy script. So the current owner should be the seller, so it should be account 2. Okay, so if we go here, let's go ahead and switch that account. So the Hardhat 1. All right. Oops, sorry. Okay, so actually the NFT contract currently owns it, so we're not going to see that right now, so my fault. Well, we'll see that update after the NFT has been sold to the new owner. So let's go back to the buyer account. So we'll just make that Hardhat account 0. Okay. And let's go through each step. So we'll be the buyer of the account 0, click buy. All right. Let's, it'll ask us to deposit 10 ETH for Earnest, click confirm. And then next transaction will pop up to do the approval, confirm. And then we should see success inside of our Hardhat account. Okay, approved sale, contract interaction. Awesome. So now let's go to the next account, which is going to be, let's see here, we've done buy. Let's do inspection. So let's look at our employer address. So inspector is the third account. So 0, 1, 2. Do this. 0, 1, 2. All right, let's see approve inspection. Click confirm. Well, let's make sure that was green. All right, contract interaction done. Now let's go to the lender. So 0, 1, 2, 3. All right, so approve and lend. Let's approve first. All right, confirm. And then second transaction comes up. This will be fund 10 ETH. All right, so both those were successful. And then let's finally go to the seller account. Hardhat 1. All right, approve and sell, 2 transactions. First transaction to approve. All right, and second transaction to finalize the sale and transfer the ownership. All right, boom, done. Now we can see that the transaction has taken place, and now it is owned by this new account. So we can go to our account here and make sure that this is the right one. And we can see that 2266 has now the address. It's owned by that. So we have the NFT. Our balance has gone down, and we can check the seller account. Received the Ether. So yeah, the seller received the Ether for the sale. So boom, we've done it. We have successfully done a real estate transaction on the blockchain with smart contracts with cryptocurrency. So that brings us to the end of our tutorial here. So I hope you like this video. Of course, there's a lot of things you can do to improve upon this. You could add searching functionality. You could, deploy this project out to a test network. You could deploy the website live to the web so that other people can do this. But this gives you an idea of the power of smart contracts and how you can completely automate this process with blockchain. All right, so that's all I got for today. So I hope you like this video. And I put a ton of time into making this and filming it just for you. And the only thing that I ask in return is that you click that like button down below this video and you subscribe to this channel. Okay, that really helps this video out so that YouTube shows it to more people. All right, it helps this channel grow so that more people can become blockchain developers. And if you like this video and you want to take the next step to really honing in your blockchain skills, land your first blockchain developer job, I guess you should do that over at dappuniversity.com/bootcamp. Okay, you don't have to be an expert to get started right away. I've helped people with zero coding experience, become real world blockchain developers in a matter of months, land 100K plus blockchain developer jobs. So that's all I've got for today. And until next time, thanks for watching Dapp University.